Hi friends, do you know one thing? In our day-to-day life, we come across many changes around us. For instance, dissolving sugar in water, burning of fuels, burning of coal or wood, setting of curd, stretched rubber band when left returns back to its original position, cooking of food and many more. In all these reactions, the starting materials is undergoing changes to either give new product or remain in its changed position. In fact, with the passage of time, our body is growing and we are becoming taller. This is also a change. Our body is undergoing changes. Friends, let's see about changes through the chapter Changes Around Us. Any alteration of a substance from its original shape, size and state is known as a change. Changes that occur around us can be broadly categorized into two, reversible and irreversible changes, depending on whether the change can be reversed or not. We will study in detail the reversible and irreversible changes. First, we are going to see about reversible changes. Changes that can be reversed are called reversible changes. Friends, what happens to an ice cream if you do not finish it quickly? The ice cream melts, isn't it? Can you change the molten ice cream back into a solid? Yes, just keep in the freezer. Molten ice cream can be changed back to its solid form. Thus, melting is a reversible change. Melting of butter and chocolate are also reversible changes. What about changes like condensation, freezing and evaporation of materials? If you take out some ice cubes from the freezer and keep them outside in a container, the ice cubes will absorb heat from the surrounding and melt. When this water or molten ice in the container is heated from some time, it starts boiling or the liquid starts to evaporate and steam escapes from the container. Now, if you hold a lid over the container, the steam will again liquefy or condense into small droplets of water on coming in contact with the cold lid. This water can be cooled down further and then kept in the freezer to form ice again. Thus, the three physical states of water, namely solid, liquid and vapor states, are reversible and can be changed from one state to another by either heating or cooling. Let's move on to the irreversible changes. The changes that cannot be reversed are called irreversible changes. There are a large number of irreversible changes that takes place around us. These changes result in a new material being produced which may or may not be useful. Some examples of irreversible changes are ripening of fruits is an irreversible change because it is not possible to get back the raw fruits from ripened or mature ones. Blooming of flowers is also an example because flowers cannot change back into buds. Milk gets spoiled when not refrigerated, particularly in summer. This is called curdling of milk or souring of milk, which is an irreversible change. Curdling of milk is also done by adding lemon juice to milk from making cottage, cheese or paneer. Burning of paper is another example for irreversible change. A new substance called ash is formed after a paper has been burned. This new substance differs from the paper in its appearance and properties. Cooking of food is yet another example of irreversible change because we cannot get back the ingredients in their original form after cooking them. For example, after a cake is baked using flour, egg, milk and chocolate, we cannot get back the ingredients. Next, the changes can again be classified into two types, namely physical and chemical changes. Changes in which no new substance are formed are called physical change. Physical change refers to the change in the physical property of the substance such as shape, size, color and state. Burning of a candle is often cited as an example of physical change because what we see immediately is melting of wax that solidifies on cooling. However, when a candle burns, the wax is undergoing two changes at the same time. First, it melts and then it burns. What burns is actually melted wax. The melted wax burns on the wick. The wick itself is not burning, it is just the wax on it. Chemical changes are those in which new substances with different properties are formed. These changes are irreversible change. Some of the chemical changes occurring in our day-to-day life including rusting of iron, silver jewelry getting tarnished or copper articles getting covered by green layer. Burning of a candle wax releases carbon dioxide and water vapor, which are the new substances. Next is expansion and contraction of materials. Some materials expand on heating and some materials contract on cooling. Heating makes the particles that form the material expand or become loose. Cooling makes the particles that form the material contract or tight. The amount of expansion differs in solids, liquids and gases. Gases expand the most while solids expand the least. We shall discuss the expansion and contraction in solid, liquid and gases with example. The example of expansion in solid is well demonstrated by the expansion gaps in railway tracks. Railway tracks consist of two parallel metal rails joined together. Small gaps called expansion gaps are deliberately left between the rails as there is an expansion of the rails in hot weather. Let's see the example for the expansion in liquids. Water expands on heating. Take a glass filled with water to its brim. Pour the water into a container and heat it. Do not boil. Now try to pour the water back into the same glass. The water overflows due to expansion in liquid upon heating. Next, if you keep an inflated balloon in the sun from some time, what will happen? It will grow in size and the air inside it expand on taking heat from the surroundings. This is an example of expansion in gases. Cooling does the opposite of heating. Cooling causes a material to contract. Solids contract the least while gases contract the most. Let's see the example of contraction in solids. If we hold a very hot glass tumbler under cold water, it cracks, isn't it? This is because the outer surface of the glass comes in direct contact with cold water and contracts more as compared to the inner surface. Next is contraction in liquids. We observe that water expands on heating. Friends, can you say what will happen if the water is allowed to cool down and then poured back into the glass? Would it still overflow? No. This is because of contraction. Contraction in gases is demonstrated by the balloon. If an inflated balloon is tied at the mouth of a bottle and the bottle is placed in ice cold water, what will happen? The balloon will shrink in size as the air inside the balloon contracts on cooling. Expansion by heating can be used in several everyday activities. So, the applications of expansion and contraction include: the jammed metal lid of a jam jar can be opened by heating. The jar is inverted and just the lid is dipped in hot water. After some time, the lid can be opened easily as the lid gets slightly expand. The fact that materials expand on heating is used in thermometers. In many thermometers, mercury is used. When the bulb of the thermometer comes in contact with a hot object, the mercury expands and its level rises in the glass tube, indicating the temperature. Why the electric lines are never hung in a good order between the poles? Wires in the outside environment are subjected to extreme weather conditions ranging from acute hot to cold temperatures. A properly arranged wire on contraction in winters is subjected to break easily. Hence, they are never hung in a good order. Friends, that's the end of the chapter. We will meet again in the next chapter. Till then, goodbye.